Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous lecture we have talked about the allotropes of carbon, and that is basically we have talked about diamond, and now we are going to talk about the another allotrope of carbon, that is graphite. So how the graphite is been prepared and what are the different properties of the graphite, and how basically graphite is comparatively different in terms of the physical property with that of the diamond. So let us talk about that also, and let us understand this topic very clearly. So talking about graphite, so graphite is basically, as a diamond was, it was a three-dimensional structure, and but in graphite basically it is a two-dimensional structure, in such a way that basically the carbon combines with that of the other three carbon atoms, while the next electron, that is doesn't take part in any kind of bonding, but it delocalizes on the plane. So what I'm talking about, let me discuss about that. So for that we should understand the electronic configuration of carbon. So the electronic configuration of carbon, as we have wrote many times, so let us discuss here also, that is 1s2, 2s2, 2p2. So in that case, suppose if I'm talking about the orbitals, so here I have mentioned about the orbitals where p consists of three orbitals in a ground state. So but what happens if we try to that is excite these electrons? So for that we have to provide certain energy, and suppose if I'm talking about the excited electrons, while mentioning about the excited state, so in this case basically I'll mention one electron, while here there will be one electron each. But in graphite basically it is not as much dense as diamond, because diamond is very much dense substance, where we could say that the density of diamond is around that 3 gram per cm cube. So that is an density, but in this case basically graphite is not that much dense like diamond. So this carbon which is present in the graphite is basically showing sp2 hybridized, while here you could see the one electron, it doesn't take part in kind of bonding, but that helps us in to understand that p orbital or that p electron that is basically used in delocalization of electrons. So it undergoes sp2 hybridization, and the one electron that has been present in the pz orbital, that is basically used in delocalization of electron. So let me discuss about the structure of graphite in a short manner. So the structure is basically this each carbon atom, when we are talking about graphite, so it has been linked with other three carbon atoms. So suppose if this is the one carbon atom, this is two, and this one will be the third one. So similarly every carbon atom will be linked with other three carbon atoms. So here it is one, if I'm talking about this is the carbon atom, so this is the first carbon atom, this is the second, and there will be a third one. So this kind of structure it will go on. And now suppose if I'm talking about the structure in this manner, so we'll find that the structure of graphite is basically like a hexagonal shape like of benzene, but this is somewhere I'm talking about a plane. So this is the first plane, and while the electrons they will delocalize on this carbon atoms, and that's the reason they will form carbon carbon single bond also, as well as carbon carbon double bond also. So this is the first layer, but the similar layer can be below it, because as I've mentioned earlier that it is not a three-dimensional structure like that of the diamond. So that's the reason it forms a 2D layer. So below a layer there will be another layer of the same graphite that I'm talking about, and that's the reason that they will have a space between them, and those space will have a certain distance, and that's the reason that they have widely applications because of this kind of property. But let me discuss about the bond between the carbon and carbon. So it has been found that the distance between, or the bond length between the carbon and carbon, it has been found to be, that is 141.5 picometer, and in a particular layer. So below there will be another layer, and that will have a difference of, that is 340 picometer distance. Another, there will be again a branch, or again there will be chain of the carbon atoms which have formed a ring type structure, and that will be also in a 2D plane. So therefore that makes the graphite to basically have an uh, unpaired electron, that is that delocalizes over the plane, and that's the reason that graphite is basically a good conductor of electricity. So now let me talk about the next property. So since they are present layer by layer, that's the reason this kind of property are basically used like a lubricant. We can't use oil as a lubricant. The reason behind that is, suppose if we try to use it in engines, because lubricants are those substances which are basically used in to resist the friction in engines and various machines. Oil, as we know, that it gives us the frictionless property, but the thing is, it can burn also, and during burning what happens is, obviously it can block the pistons and all the and various machinery activities. But if we try to use graphite, so graphite is, it has a layer on layer structure, so that's the reason that it is used as a good frictionless basically substance, and that's the reason it is used as a lubricant. And the moreover I am talking about, that is, it doesn't conduct heat too much, or it has a tendency to absorb heat, and it will not get burned easily. So that is the reason they are been used in various industries as well as vehicles also. Basically the graphite lubricants are been used in making machines as well as in working of machines. So so therefore these are the various property that I was talking about. And as well as we have also discussed about the hybridization of the carbon in the graphite, and this is what it is comparatively different from that of the diamond, and that is what I want to talk about. So this was graphite, the fullerene of a carbon. So thank you friends for watching this video. I hope you have understood this video very clearly, and you have got to know the various applications as well as the different properties of the graphite. And I hope you'll share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.